All right, so if you take a look, what we were doing yesterday, we introduced the concept of the sine and cosine waves and where those posters up here came from, okay? And we kind of built the sine wave and the cosine waves. That was the main idea from yesterday. We even looked a little bit at if you have a horizontal shift where it doesn't start right on the y-axis, how to then build it from there. We looked a little bit at that, did some examples with that as well. What we're going to do today is we're going to kind of put it all together. Okay? So if we go through and you have a horizontal shift, you have a vertical shift. What if you change the amplitude and therefore it's a vertical stretch? Those types of things. So that's the difference between yesterday and today, is we're now going to kind of put it all together. Okay? So that's where we're headed. So reminder, here's the sine wave and cosine waves that we ended up with yesterday. Okay? Just as a reminder. Biggest reminder, a couple things. Remember, a sine wave in general, before we get going here, starts at a midline point, okay? Starts at the origin and then goes up to a maximum value and then goes from there, okay? Remember again, as we were graphing this yesterday, we took the entire period, divided it into 4 equal parts, because every fourth of a wave, you have an important point. You start at the origin, 1/4 of the way gets you to a maximum, next fourth gets you to the midline, next fourth gets you to the minimum, and then right back to the beginning again, okay? So we're always going to, when we're graphing these, we're always going to take the period and divide it by 4, okay? Because of that property or that idea. Only difference on a cosine wave, remember, is that it starts at a maximum instead of a midline point and then goes from there. But otherwise, everything else is pretty much the exact same thing, okay? So just kind of a quick refresher. So here's your transformations. Here's what we're going to do today. Okay? Here's kind of the main slide in terms of the information that you need. So transformations of sine and cosines. Like I said, we're going to put everything together. So here's your first off, regardless either sine or cosine, there's your general equations right there for sine and cosine. And we'll explain what A, B, C, D, all that stuff means. And so again, as we get into this, as we talk about this, the first thing when you're graphing an equation, the very first thing you want to look at is, am I dealing with a sine wave or a cosine wave? That way you know, am I starting at a maximum if it's cosine, or am I starting at a midline point if it's sine? Okay? So that's the first thing you always want to take a look at. Is this a sine or a cosine problem? Then we'll start looking at all the parts, the details. Okay? So first off, that A value that's in front of the sine or the cosine, that A value is your amplitude, okay? So everything we did yesterday, we didn't change the amplitude at all. We said maximums occurred at 1, minimums were at -1. Every sine and cosine waves were between 1 and -1. But we could change that number. We could change it to 2, we could change it to 3, so on and so forth. So what it will do is it will stretch that wave vertically. It'll be a steeper wave up and down. Okay? Go up to 3, down to -3. Up to 5, down to -5. That's your amplitude. Okay? The B value, if we move to that, the B value by itself doesn't necessarily tell you a whole lot. But to find the period of your sine or cosine wave, okay, the period is always 2 pi divided by B. That's how you find the period of a sine or cosine wave. Period is always 2 pi divided by B. And then once you have the period, we're then going to take whatever that is and divide it by 4 so that we can use it to graph like we did yesterday. Okay? But that's how you find your period. 2 pi divided by B. Then we get into C. That deals with, for whatever reason, when you get into trig functions, when you do the sine and cosine waves, They call it a phase shift instead of a horizontal shift. It's quite literally the same thing, okay? To find your horizontal shift, you take the opposite of C and divide it by B. Okay? Opposite of C and divide it by B. I'll give you a second way to think about this, but that's your horizontal shift. Like I said, with trig functions, they call it a phase shift for some reason. That's what we did yesterday, except I just told you sine wave, but starting at pi over 3, or starting at negative pi over 4. That's what your phase shift was. I just gave it to you yesterday instead of having you find it, okay? So one other way to think about this, other than the opposite of C over B, notice that B and C are in parentheses. You could think back to basically like zero product property when you factor. If you just take what's in parentheses here and set it equal to 0 and solve for x, turns out that's your phase shift, because you're going to subtract C and then divide by B. Okay? So that's another way of thinking about it. If you just set the stuff in parentheses equal to 0 and solve, you'll get your horizontal shift. Okay? And lastly, D is your vertical shift. That'll take the entire wave and move it up or down however much. Okay? D is your vertical shift. And so biggest thing that you're going to take is, when you do the vertical shift, we're going to take that midline and move it up or down, and then the amplitude will work off of that. And I'll show you once we start doing it. But that midline that normally is the x-axis, that's we're going to move that midline up or down, and then we'll do the amplitude off of the midline. Okay? So this is everything that could happen in a sine wave. Okay? You get everything. You could change the amplitude, we could change the period, we could change the horizontal and vertical shifts. Okay? And you'll have some problems where you have everything involved. But we'll start off with kind of mainly a warm-up, almost a review from yesterday real quickly. So here's your first one. Like I said, this is more just kind of a review from yesterday of what we did. So first thing I'm going to do, there's not a whole lot going on here, okay? But first thing I want to do now that we're talking about everything, I want you to identify the parts. What is the amplitude? What is the period? What are the different shifts that are going on? That's the first thing. So let's start with that. Amplitude. What is our amplitude on this one? It is 1. Yep. It's a number in front of whatever the sine or cosine, okay? So our amplitude is 1, which means wherever our midline is, we're going to go up 1 and down 1 from there. That's where our maximums and minimums will occur. Okay? Let's go to the B value next. What's the value of B on this one? Also 1. It's the number in front of the x. Okay? And since B is 1, that doesn't mean the period is 1. Okay, remember, what that tells you is the period then is 2 pi divided by B, which in this case, that means the period hasn't changed. It's still 2 pi. Okay? So we've got an amplitude of 1. We have a period of 2 pi. Let's go to I'm going to just abbreviate PS, phase shift. Okay? Or horizontal shift, like I said. Okay? Phase shift or horizontal shift. On this one, opposite of C over B. Therefore, what's my phase shift? Or, like I said, take what's in parentheses and just solve for x. That'll tell you the phase shift, which means it's pi over 3. If you did opposite of C over B, here's your C value right here. So you would have positive pi over 3 divided by 1. So we're going to take this entire graph, we're going to move it pi over 3 to the right. Okay, we're going to take the entire, in this case, the entire cosine wave is going to go pi over 3 to the right. And last part, our vertical shift, I'm going to abbreviate that as well. Do we have a vertical shift? No, there's nothing either at the beginning or at the end that's added or subtracted, so there is no vertical shift. What that tells me is the midline does not go up or down at all then. Okay, so there we've identified everything that we have Now let's start to put it together. Okay, let's start taking a look. So that means if there is no vertical shift, we know the midline is still the x-axis. If the amplitude is 1, that means I know the maximums then are going to be at 1 and -1. We can put those in there, okay, because that's always from your midline. You're going up and down the same amount. Phase shift, we said horizontal shift is pi over 3. So let's put that in. We're going to put pi over 3 here. That's like yesterday. That's like our starting point. And now, and we'll come back with the period and start working on this. Here's where I was talking before, cosine graph. Where do we start? Okay, yep, we start up here at a maximum. We start at 1. Okay, cosine graphs start at a maximum value. So that's the first thing you always need. You need something to start with. You need a starting point. And then from there, we can use that period divided by 4 to start graphing the rest. Okay? So if we take the period and we divide it by 4, we get 2 pi over 4. And remember yesterday, we said we want a common denominator between that and our starting point. So let's change these into 12ths. Okay? So if we multiply this one by 3, we get 6 pi over 12. If I multiply this one by 4, I'm going to actually change this starting point to 4 pi over 12. And now, like we said, if 6 pi over 12 is 1/4 of a period, every fourth is the next important point on your wave. So if we add that to what we started with, that means the next important point will be 10 pi over 12. And what point do I have? If I'm starting at a maximum, next point would be? Midline. Yep, very good. There's our next one. We're at a midline point now. Okay. Then we add another fourth to that. So now we're at 16 pi over 12. And that point will be down here. That's a minimum value. And we add it again for the next part of the wave. Now we're at 22 pi over 12. Back to a midline point. And one more time, we're at 28 pi over 12. And we're right back to your maximum value. And here's at least one cosine wave. Okay? There's one full period that in this case is the only difference was we shifted it pi over 3 to the right. Okay? Otherwise, it's the exact same thing as this parent function. Okay? The one that's up here on the poster. It's that exact graph just shifted pi over 3 to the right. Okay? Amplitude's the same, everything else is the same. Okay? Questions on any of that? That's more, like I said, this is more of a review. This is pretty similar to what we did yesterday. Quick question then on a few different problems. I'm not actually even going to graph these. I just want you to kind of tell me what's happening or what's going to happen. So if we take a look at this, for example, like I said, I'm not even necessarily going to graph these. Number 1, what would the only difference be on this graph? Yeah, the amplitude is a half. So instead of going up to 1 and down to -1, you'd go up to a half, down to a -1/2. Okay, that's where your sine wave would. And since it's a sine wave, where would it start? At the origin. It would look something, I would start right here, and you'd have your wave. This would be 1/2. This would be -1/2. Only difference. Okay? What about number 2? What's the only difference? Amplitude again. Now we're going up to 3, down to -3. So now it'll be a much steeper wave. Okay? What about number 3? See if I haven't technically talked about this, but we've talked about it in general before. The fact that that's negative, well, what effect would that have on the actual graph? It's a reflection. So on this problem, back on number 2, we would still start at the origin and we would go up to 3, down to 3, and back. Okay? Here would be 3 and -3. When you've got a negative amplitude, the amplitude is still 3, but the negative takes that graph and reflects it. So instead of, we would still start at the origin, but instead of going up to 3, we actually go down to -3 first. That's the effect that negative would have. it's a vertical reflection. So instead of up to a maximum, it actually goes down to a minimum. That's the one difference. Okay? And so that's kind of the main idea. I wanted you to kind of at least see a couple of those. Let's actually put this all together. Let's do a couple of examples putting it all together here. Okay, so take a look at this one. We're going to graph this. Ignore the fact that it says number 9. This is off a worksheet. This is off a different worksheet. Well, let's go through and let's put this all together. And we'll start in the same spot. Let's kind of identify the features first. What's my amplitude? What's my phase shift? What's the period? Let's identify all those parts before we actually start trying to use them. Okay? So number 1, what is the amplitude of this graph?
3.
Yep, it's the number in front of the cosine. So we have amplitude of 3. Okay? B value. What's my B value? 2. That's the number in front of the x. Okay? Which tells me then that the period is 2 pi divided by b. Which means what's the period of this cosine wave? Pi. Yep. So that b helps me find the period. So that means the period turns out to be pi. Okay? 2 pi divided by whatever b is. That always gives you the period of the wave. Okay? So we're going to complete a full wave over the course of pi rather than 2 pi. Then if we go to the phase shift, let's go to that next. What's my phase shift on this one? Don't overthink this. What's my horizontal shift? There isn't one. Nope. Because if I take, so 2 different ways of thinking about it. If you think about it as the opposite of c divided by b, technically c is 0. You're not adding or subtracting anything in parentheses. So you'd have 0 divided by 2, which still gives you 0. Or again, remember, if you just take what's in parentheses and basically solve for x, that gives you the phase shift. So in this case, we do not have any phase shift. We're not moving this left or right at all. Okay? Last part then, vertical shift. Do I have a vertical shift on this one? Yep, what is it? We're going up 2. We're going to take the entire graph and move it up 2. All right, so let's put this whole thing together then. Let's actually get rid of that. So here's our x-axis. We have change something quick. All right, so if we now take a look, now let's start putting things together. So the vertical shift moves that midline from the x-axis up 2 units. So I know that the midline of my actual graph is going to be right here at 2. Okay, we'll come back to that. That's where the midline is going to be. Which means, let's see if you put this together, where's the maximum value is going to occur? 5. Because you got an amplitude of 3, and from your midline, you need to go up and down that amount, okay, that distance. So that means maximum values will occur at 5. Minimum values will occur down here at -1. That's where your graph is going to be. The entire wave will be between -1 and 5. Okay. Now, I don't have any phase shift, so I'm not moving anything left or right. So let's start with our starting point, since I don't have a phase shift. Cosine graph starts where? Maximum or midline? Maximum. Okay? So we are starting our graph right here up at 5. And now, just like always, to now find all the rest of the points that are on this wave, take the period, divide it by 4, and just start working your way through the process. Okay? So if the period is pi, that means every pi over 4 is going to be the next important point on our graph. Okay? And since I'm starting at 0, I don't have to worry about a common denominator or anything. So let's say we put here pi over 4. we go from maximum. Next point will then be a midline. We add another pi over 4. And you can leave this, I think I told you this yesterday, you can leave it as 2 pi over 4. Could you reduce it to pi over 2? Absolutely. I think it's easier because then as you're just, if you leave it, then you can just keep common denominators. You don't have to worry about it. Okay? So 2 pi over 4 means now we're down here, and technically I'm going to be right in the middle of my, what I just labeled. Minimum value right there at -1. We go another pi over 4, so now we're at 3 pi over 4. We're back to the midline. And 4 pi over 4, or pi, we're back to our maximum. Notice we said the period is pi, which means I should be able to complete one full wave. Well, here it is, right here. There's your one full wave over the course of pi. Okay? 4 pi over 4 is pi. And normally what I'm going to have you do is I'm going to have you complete 2 full waves when you're graphing these. So I'm not going to do it right now, but what would I do? Just to save time, I'm not going to do it. But what would I do if I wanted a whole nother wave? Just keep adding pi over 4. Just keep going. And you'd have 5 pi over 4 would be the next point. 6 pi over 4. 7 pi over 4. Just keep going. Okay? You just don't stop after one wave. You just keep going and cycle through a whole second one. Okay? So this one in general, the only thing we didn't have was a phase shift. We had a change of amplitude, we had a change of period, we had a change of vertical shift, so the midline shifted. The only thing we didn't have was the starting point didn't go left or right. Otherwise, everything that could happen is there. How we doing? You guys feeling okay? Making sense, hopefully? Okay, let me give you one more. And then I'm going to try to give you some time in class so that you can at least get started, and if you're struggling, you can ask some questions. All right, let's go same thing again. Let's identify all the parts first, and then we'll use them to start moving forward. First off, what is our amplitude of this graph?
-3.
And I'm still going to say, here's what I'm going to have you do. Rather than put down -3, I'm going to tell you that the amplitude is 3, but in parentheses, I'm going to have you kind of remind yourself, what does the negative do? It's a reflection. So I'm going to put down, you've got an amplitude of 3, but with a reflection. Okay? Just to remind you that when you graph it, you got to reflect it. All right, what's our B value on this one? 2 pi is the V value. So rather than a number, just like 2 or 3 or 5, it's actually 2 pi on this one, which means, what's the period? 1. Okay, that means that the period is 1. Now, it gets a little bit confusing sometimes because you might think, well, 1 what? 1 radian is the period. So most of the times when you graph these, you're going to be going, you'll have a pi on the x-axis. You'll be going by pi over 2 or pi over 4 or some value of pi. However, every now and then, they'll throw in one that's just in radians. It actually makes it easier, to be honest, because now you're just dealing with numbers, and you don't really have to worry too much about any of the pi's. Okay? But that's what that represents, is your period is 1 radian. It's just not in terms of pi. Okay? Let's go to phase shift. What is our horizontal shift on this one? Yeah, if you basically, again, opposite of B, -4 pi, divided by 2 pi, you end up with a phase shift of -2 radians. Again, that's why there's not a pi in it. -2 radians. Or, once again, take what's in parentheses and just solve for x. Subtract the 4 pi over, okay, and then divide by 2 pi. Set it equal to 0 and solve. And finally, vertical shift. What do we have? Nothing. There's nothing in the front that's added, there's nothing at the end that's added, so we are not shifting this up or down at all. Okay? So there's your information. And now we start working our way, actually use it to create this, once again, this cosine wave. Okay? So we're starting here. This is one where, since there is no vertical shift, I'm going to leave the y-axis, because notice, since my phase shift is -2, we'll put that when we switch from negative to positive. I'll throw a y-axis in like we did yesterday. So let's say that is our -2. Starting off, again, cosine wave, which means normally we would start up here as at a maximum, but because we have a reflection, I must have erased that on accident, that means instead we're actually going to be starting down at a minimum value. So we're starting down here at whatever the minimum is, okay, which we'll put in a second. That's because the amplitude is negative. Rather than starting at a maximum, we're starting at a minimum. Okay, does that make sense? Okay. And once again, now we work our way through and just take the period, divide it by 4, and just start working your way through everything. Period in this case is 1, which means 1/4 of the way through, you're just going to keep adding the numbers. Okay? So in this case, if we do that, the next point that we would have, if I add 1/4 to that, okay, or 0.25, then we're at -1.75, or -1 3/4. What will happen at that value? Midline, maximum, or minimum? Yep, we go up to a midline. What's the next point going to occur at? And it's going to be -1.5, another 1/4, okay, the 1/4 of the period. That will be up here at a maximum value. Then we go another 1/4. So now we're at -1.25 radians. We're back to our midline again. Then we're at -1. Back to our minimum value. And again, so here would be one complete wave. And let's say we wanted 2 waves. Like I said, on your assignment today, I'm going to ask you to complete two full periods, 2 full waves. We would just keep going. Add another 1/4, another 1/4, another 1/4. Let me put in the y-axis here since we never did that. We put in our y-axis. Our maximum and minimum values occur where? What numbers? Yeah, amplitude is 3, and I didn't have any vertical shift, so that means we're going up to 3 and down to -3. Okay? So there's at least a sketch of one period of the graph. And like I said, the only difference if you want a second period, just keep going. Okay? Just keep going for another period. How we doing? Not too bad, hopefully? Okay? This is, like I said, and what we're going to do today, I'm going to give you some time now. I'm going to give you about 15 minutes here where you can start working your way through it. I would highly suggest do not rush. Don't try to race your way through it. These are ones where you got to identify what you have and really kind of think it through. Don't rush your way through it. Make sure you do a good job at it. Now, the more you get used to it, then the easier it should get and the quicker it'll come to you. But especially at the beginning, take your time and think. Okay? I'll give you some time in class today to work. Tomorrow is just going to be questions and more practice. Okay? Tomorrow will be questions and more practice. I'm not sure if I mentioned it yesterday to this class or not, but let me mention it real quickly. So next week coming up, this, by the way, so today we're doing this stuff. Tomorrow I told you just practice. Thursday and Friday we're going to go the other way. And what I mean by that is instead of having the equation and coming up with the graph, we're going to either give you the graph or give you information about the graph and try to come up with the equation, just working backwards. And that's the end of this first part of the chapter. That's what we're going to test on. So next week, Monday and Tuesday will be review days. We'll have 2 review days. And then this is going to be another one of those 2-day tests, mainly because there's a lot going on. And like this type of stuff, you want to be able to think it through a little bit. You don't want to be able to rush it. So it's going to be a 2-day test. Day number 1 will be no calculator, but you'll have your unit circle. okay? So it'll be problems like, what's the sine of 2 pi over 3? What's the cosecant of, pi? Things like that where you're using your unit circle and you don't need a calculator anyway. Or what's a coterminal angle to some other stuff. Kind of what we did in the first half of the chapter. The day number 2 will mainly be graphing stuff. Like basically what we are doing this week will be the great majority of day number 2. And that day you'll have, you won't have a graphing calculator because obviously we're graphing, okay? But you'll have a calculator to use if you need to do computational stuff. Okay? So just a heads up on that that's what's coming. That's what the test will kind of look like. Okay? All right. So for today, I'm going to give you 6 whole questions. Okay? Let me give you the assignment, and you can, like I said, you got 15 minutes here to at least get started and ask questions if something's not going quite right.